this direction. If I2 is negative, then it's in that direction. How about I3 now? Well, let us assume that I1 is plus 3 amperes. And that you find that I2 is plus 1 ampere. That's possible, right? You have two equations, two unknowns, and these are the answers. So 3 amperes goes like this, down, and 1 ampere comes up. Well, it's clear then that I3 is 3 minus 1 is plus 2. Another way of looking at it is 3 amperes come in at this juncture. I2 is 1 ampere, so 1 ampere goes through, so 2 must go down. That's really Kirchhoff's second rule. If I1 were plus 1 ampere, and I2 was also plus 1 ampere, then I3 would be 0. No current would flow through I3, but my method would still work. I find 1 ampere going down and 1 ampere going up, so there's no current going through R2. There's only current going in this direction, 1 ampere. And so, you have to recognize then that I3 is I1 minus I2, which is really application then of Kirchhoff's second rule. I like this idea of a closed loop current. I know some of you don't like it. It's fine. The reason why I like it is I always end up in this case with two equations with two unknowns. I solve for I1, I solve for I2, and then the third one comes out in a natural way by just thinking, one current goes in this direction and the other goes in that direction. But if you prefer the method that the book will present to you, you get 3 equations with 3 unknowns, and you get I1, I2, and I3. Right at the start you get an I3. You see, I don't even start off with an I3. It's not there, it comes in later. So the choice is yours. Now I want to entertain you for the last 6 minutes with something amazing. Something that is truly amazing. And it is a form of a battery that is mind-boggling. And the battery is right here on my left, on your right. It is a battery that produces an enormous potential difference. 10, 20 kilovolts. You see a schematic here on the transparency. You have a bucket of water here on the top, and you have glass, and the bucket of water is hiding behind here. It's not that because we hide it from you, but that's the best place to be. And you see plastic tubing coming down, and the water can run out on the right, and it can run out on the left. It runs out here. There is some paint can, no top and no bottom. And you see this paint can here. It's completely open. There's a letter A. And there's another paint can on the right. There's a letter B. It's a conducting can. This is also a conducting can. And this water runs into another conducting trash can. And this water also runs into a conducting trash can. And now comes the key point. That this conductor here, A, is connected through a conducting wire with C, and the conductor B, the paint can, is connected with a conducting wire to this trash can D. You let the water run for a while, and you will see between these 2 points here, sparks. Even when the points are as far apart as, say, 5 millimeters, when you're talking about at least a potential difference of something like 10, 15,000 volts, you will see the sparks. And you wait, see another spark. And you wait, and you see another spark. So this is a power supply. And there must be energy coming from somewhere. And so problem 4.1, which you haven't seen yet on your 4th assignment, is asking you how this works. I will demonstrate it today, and I will come back to it later. The way it works is actually quite subtle, but I want you to think about it. It's a remarkable battery, a remarkable power supply. As the water starts running, I want to draw your attention to the fact that you can almost anticipate when the spark occurs. Because the water at the very last is beginning to spread. It doesn't come out anymore just like a narrow cylinder, but it begins to spread. And then comes the spark. And then it goes back to running normally, and then slowly in time it will spread, and then comes the spark. So let us get it going. You have some light here. Marcos and Bill spent a lot of time getting this going. Marcos, do I have all my lights the way you want them? You're happy with that. There you see the two balls, which are really here. And let's first look at the sparks. So I will start the water running now. Let's just be patient a little bit. And let's see where we're seeing spark. Did you see one? Did you see the spark? Oh, you were not looking. Man, you're paying for this. Look at the two balls. Give it some time again. Have to charge up. I can already anticipate it's coming up. It's coming up. Yeah! Did you see it? 15,000 volts. Let's give it a little bit more time and then we'll take a look at the water flow, which I can see. I'm close. But we can make you see the water flow. Look again. It's coming up. Did you see it? I could see it coming up. I can make you listen by having my microphone near the water, and you can hear this water running. Familiar sound to all of us. And now the sound changes. You hear change, and there's a spark. Once more. Just running. Spreading. Coming up. Yeah! Amazing, isn't it? I can make you see this water. Just stay there. We have 1.5 minutes left. So now you can see the water. You happy with the light, Marcos? You can improve on it. So look at the water. It was just spreading already. You can't see the spark and the water at the same time. So the water is running now normally. It's going to spread slowly. I will tell you when I see the spark here, but it's already, I can almost predict when it happens. The water is spreading now. Coming up shortly. Yeah, I saw the spark. And you immediately see the water go like this. I want you to think about it and explain this. This is one of the most remarkable things I've ever seen in my life.